I hope you're seeing my slides now.
Okay, yeah, I can see slides, so go ahead.
Great. Hi everyone. Nikos is the shorter version of my name. A little bit about what we will see today. We're gonna take a look at digital skimming attacks, or e-skimming attacks as they're also called. And we're gonna take a look at a method of detection, like how to detect ongoing digital skimming attacks in order to stop them. And this detection method is intended to be used by application security specialists or IT security specialists, or those programmers who are into security. And we will take a look at the characteristics of these attacks, and then we'll take a closer look at how the detection method works. And if we have time, we will also look at a demo, a short demo. So let's get started. Some extra things maybe about me. I have some background, as we said, in development research. I worked in telecom finance, and I do application security since 2017, which means threat modeling, web application security testing, education, and so on. And we are, myself and a few other people, leading the local chapter in Stockholm. So you're very pleased, welcome to contact us if you would like to present your own work, and we will be happy to arrange that. But to the point of this talk, let's start by talking about skimming attacks, and we will start from the physical world because that's where they initially appeared. These kind of attacks usually happen at remote location where you have payment machines, ATM machines, gas stations, places where they will accept your credit card. And what the criminal will do is that they will usually have a digital device that they will place on top of the actual receiver of the credit card. And this is called like the skimmer. And what they will do is that they will target the magnetic stripe of your credit card. They will copy the data and store it locally on the skimming device. That's like the standard type of attack. Of course, they go after your credit card information, and they pick remote locations because at a later stage, the criminal will have to pass by, collect the digital equipment that looks a lot like the actual thing, the actual receiver of the credit card, so that you will not be able to detect it as seen in the image. And they will collect the loot, the collected credit cards, and then just sell them further on, probably to the dark web or other places. One characteristic of this attack is that functionality is not broken. You will still get your money, you will still make your payment, but you will not really realize you're being attacked unless or until your credit card information is actually used by another person at a later stage. Let's make the jump at the digital world now. What are digital skimming attacks? There is a term that is used broadly whenever someone is talking about digital skimming attacks, and that umbrella term, it's mates card. So mates card is a term used for several groups doing the same thing, and that is stealing credit card information from websites and from victims who are inserting their credit cards into these websites in order to pay whatever service they are buying. They are quite notorious, and that's probably why they made it to Wired's most notorious people online of 2018, together with some other really interesting personalities. Europol has also an assessment of 2020 where they have a whole section about them. And there, this group is actually referred to as a group doing attacks using JavaScript. And their goal is to inject a skimmer code or a piece of JavaScript onto payments web pages, and then steal the credit card. They use a drop server, so that's like the server where they collect the stolen credit cards, and then they sell them onto the dark web. So that's quite similar with physical attacks, but in the digital world. a little bit more context, that their targets are usually medium-sized or small-sized web shops, and that's probably because these types of web shops are not focusing as much on security as bigger corporations do, and that's what the image on the right is all about. It tries to show that there is a broad spectrum of types of web shops that are being attacked, with a special focus on miscellaneous and specialized, which for me means smaller, medium-sized web shops. Traditionally, the Magento platform has been a target of their attacks, and that's why the Magento platform has been used to can be used to create exactly this type of web shops, small and medium sized. And by finding a vulnerability there, of course, they are able to hack hundreds, maybe thousands of websites at the same time and then deploy their skimmer codes. But that's not the whole story. They have also some more popular targets, which include Macy's, British Airways, Ticketmaster, Forbes, and so on. Characteristics of these attacks that are that they are hard to identify. You have to be monitoring. You have to realize that something happens in your production. That's not really straightforward as it sounds. It might be hard to notify victims and to notify the companies being affected. The bank might reside in one country and the website might reside in another country. That makes it really hard for law enforcement to actually do its job, and everything will probably end up in dark web, where there are specialized dark web websites that are selling maybe even skimmer code itself, but also stolen credit cards. As a result of their attacks, there have been some headlines in the news. British Airways, they were initially fined with a huge fine of, I think it was around 183 million British pounds or something. That was later reduced to 20 million, still quite a substantial amount. And Ticketmaster also had to pay their own fine for their breaches by Maidcard. And these figures, of course, do not include settlements and damages that have to be paid to victims, legal fees included, and of course the damage and reputation that you cannot really put a dollar value on, right? Let's start getting a little bit more technical. So what happens in practice? You have a payments form, and what happens is the victim will go in, fill in the credit card information, the name on the credit card, the CVC code, and so on. And on this page, you obviously are running JavaScript. The World Wide Web is running on JavaScript, more or less. And this JavaScript, of course, translates to code, to source code that instructs the browser on how to react to inputs to the payment form and so on. That's like how it works. What these criminals will do now, and this is the critical point, is that they will find their way in, they will breach security somehow. We will check a few cases, and they will inject their skimmer code. And that skimmer code is what will listen to whatever you're inputting in your payments form and then send it to the drop server, as we have already discussed. So that's like the bigger picture of how these attacks work. And they usually choose to inject this skimmer code in existing scripts because that makes detection even harder. Now, let's take a look at the first case. That is the British Airways case, like the most famous case. And the characteristic of this attack is that this was an attack targeting British Airways and only British Airways. It's different from the Magento platform, where you find a vulnerability in the platform and then this is exploitable in thousands of websites. That's another case. Here, they went directly for British Airways infrastructure because they found some kind of vulnerability and they breached British Airways. And that attack, the actual breach, happened about a week before the actual skimming attack started, as we know so far. And we know that because a certificate was bought from Komodo, was registered about a week before the actual skimming attack. Now, parenthesis open, the actual fact that they could acquire a certificate from Komodo and register baways.com domain for their own use. That looks a lot like British Airways domains, but it is not. Is maybe a topic for a whole another talk, but yeah. Parenthesis closed. In this particular case, they went for a script called Modernizer because that probably felt maybe it was from payment forms or payments web pages of British Airways. They were, by hacking the website, they were able also to hack the mobile application of British Airways because the mobile application was actually mirroring parts of the web page. So the skimmer code was also affecting the mobile application. And as a result of this attack, 380,000 victims were lost credit card information to the attackers. And that happened because of 22 lines of code. And this is what these 22 lines of code looked like. This is the deobfuscated form of the actual skimmer code. And we don't really have to be a Java ninja, JavaScript ninja to understand what is going on here. This is like an action that is binded to the submit button on the payment form. So as a victim, you would go in, you will fill in your information, and by the time you release your click from the submit button or your touch from your touchpad from the button, what this functionality does is that it serializes the form where you have input your credit card information, your name, your CVC code, and so on. It will serialize all the information and just post it. It will do an HTTP post to this baways.com domain. That is the drop server that the Matescard group used to collect all stolen credit card information. Simple, straightforward, effective, characteristic piece of these types of attacks. Let's move on and look at yet another case from Ticketmaster. This case I want to pick up because it looks, it shares some characteristics with the previous case. Of course, they went after the credit card information and they used the drop server and so on. But instead of going directly for Ticketmaster, like hacking directly in their infrastructure, they went through a third-party provider, in this case Inventa, which was a provider of functionality as a third party. So Ticketmaster was injecting their scripts from their own domain into their Ticketmaster websites. So what the hackers did is that they breached Inventa, injected their skimmer code in their scripts, so the actual skimmer code got reflected in Ticketmaster web pages. And in this particular case, they did not just inject their skimmer code in one script. They had chosen several scripts to inject their skimmer code in, probably because that's how they felt functionality for them would work better. And yeah, as a result, the skimmer code was working and credit cards were being stolen. So let's make a quick summary of what we discussed so far. These attacks happen through JavaScript. That's like the main path to deliver the means to deliver the attack. They might go through a platform there that the web shop is being built on, finding very exploitable problems there and then affecting thousands of websites, or they might go directly for infrastructure if that's a more like a bigger target, a bigger victim they are interested in, and they find they are quite opportunistic, right? So they find an opportunity, they will take advantage of that, or they might even use third-party providers or advertisements or something that are being reflected in your web page, and by hacking them, they are able to hack the actual victim they are going after. So I would like to take a brief discussion on what is already out there about the detection, which is the high point of this talk. First of all, security basics and security hygiene is very important. Patching, of course, keeping the infrastructure at the latest version is like the bottom line that every security team, every company should be doing. That if you're not doing that, then you're obviously doing something really wrong with security. And the equivalent to patching infrastructures, of course, for the software world, keeping your third-party components, open source components, third-party components up to date, because that makes sure you do not have any known vulnerabilities, at least in your running applications. Another important aspect is that it's really nice to assess the risk of third-party providers. That means doing your due diligence for the code, the functionality that you're actually integrating into your own platforms and your own websites. And then there are a bit more technical ways to differences, and that is content security policy. If you're not aware with what content security policy is, simply put, it is a way to instruct your web browser on which domains can run scripts, can run images, can run CSS on your own web pages. So by doing that, you make the life harder. And then in case you need to run inline scripts, there are also ways to essentially assign an identity on your inline script that the browser can check. If that changes, the identity will not match and it will block your inline script from running. There are two ways to do that. We will not talk details. You may Google that further on. That's known source and hash source on how to do that. And in the case of third-party providers or CDNs or loading scripts from another domain, there's also sub-precious integrity, which includes an identity or an integrity code for the script you are injecting from a third-party provider. And if that code changes on the third-party provider, the integrity will also change and the script will be stopped from executing. We will talk we'll talk a bit about what hashing is in just a second. So there are tools, there are ways to at least make the life of the attacker way harder. There might be ways that they can circumvent these defenses, but that would be way more difficult to do compared to not having, of course, especially content security policy and sub-precious integrity that I'm talking about, because patching and keeping third-party components up to date is a must for everyone. But I would like to take a moment to talk a bit about detection. These methods that we have just talked about, they are not present everywhere, and there is a good reason for that. There are means, there are ways to implement them, but it's not straightforward for all development teams. So there might be that your development teams, if you're working in a bigger corporation, do not have the education needed to actually implement this. And they might not have the resources to do that. And if you're a developer working for a smaller company that maybe administers several smaller websites, then you might be also missing the education to do that, or you might not have time to do that. So the reasons can differ from company to company. So as talking about myself as well, as an application security or an IT security specialist, I would really love to have a way to keep an eye on what is happening on the production of my company without relying on others. So I would like to have a way to do detection on with my own tools and my own means. And that's what this talk is about presenting a method to detect digital skimming attacks, being separate, being detached from developer teams, being able to do it on your own. And the means to do that, the way to do that, is through one-way hash functions. And you don't need to know too much details or too much crypto in order to understand what the cryptographic one hash functions are. Simply put, again, it's a cryptographic function on a pre-image. The pre-image can actually be an actual image, or it can be source code, it can be text or whatever. So that's called the pre-image. You apply the one-way hash function on that pre-image and you get a hash value. You get a hash in the end. And this hash value will be unique for its pre-image. So you change the pre-image, the hash changes as well. That's the main functionality. And you go fast from the pre-image to the hash, but it's not as easy to go backwards. So how do we apply that? Back to the example where you are loading some JavaScript with source code, of course, on your web pages. You get the source code and you apply a one-way function on that piece of code. In this case, I'm giving an example that's SHA-256, which is one of the available cryptographic hash function that you can use. So you get the output, you get the hash value, right? At a later stage, let's suppose that an attacker is injecting code, but you're repeating this process. You're taking the source code again, and you are applying a cryptographic hash function on that source code, and then you get the hash value. If you compare that new hash value to the old one, you will realize that it changed, and that's because the source code changed. So that is a way to detect that something happened in your production. That's a way to detect that the source code changed, and that's a security event that needs to be investigated further. So in order to automate this process, what I did is that I created a GitHub project that I call Suricata.js from the lovely animal. You know, it's always on its toes and alert. It's written in Python. It's really simple. It's not a very advanced piece of code. You can you're very welcome to extend, overwrite, totally destroy, or use it. It's open source, and the functionality is as follows. It takes an input in a target.txt file where you provide the URLs that you're interested in monitoring in your production. And what it will do is that it will scan this whole web page. It will identify inline scripts, reference scripts, and so on. And if it doesn't exist in its database, the script, it will hash it and put it in the database. If the script has been checked before and exists in the database with its hash value, it will recompute the hash value and compare to the one that exists in your database. And if they don't match, it will create an alert. So that's like the functionality of Suricata.js. And at this point, I think I have the time to show you a demo. So what I did is that I created a very simple payments form on my local host where you are supposed to go in and provide your credit information. And what this page does is that it simply runs a JavaScript code that says, yeah, thank you for submitting your credit information. That's like this piece of code seen here. That's very simple, just an alert. So what I will do now is that I will go back to my Visual Studio Code and I will run Suricata. I have already done that, as you see above, but just I added some verbose output here that says, I found your script and the checksum that already exists in the database is this one and it matches the database. So nothing to worry about here, right? Now, suppose my website is getting breached and I will act as the attacker and I will simply add this piece of skimmer code. And what it does is that it takes the web form that we see, and it just sends that to a webhook site. So that's my drop server, right? So let's do that. Let's suppose I'm buying something. And yeah, that's how it looks like. It's I'm getting the input I inserted and the CC number and expire. So that's like how the skimmer code would look like, and what the collection of the credit card information on the drop server would look like. Now, what do we do as a defender? If I run Suricata again, it will detect a change. So it tells me that warning, a new hash value has been detected, which doesn't match the records in our database. Please check that out. And that's more or less what Suricata does. Let's go back to the presentation, because I think I have one more slide to show. Yes. So as I said, you're very welcome to provide feedback, extend, help me out further developing this tool. And one piece of advice on how to integrate that in your existing monitoring platforms, if you're interested, is alerts for yourself are not fun. I've done it myself. I've seen colleagues doing that. This is a tool that creates some security warnings, right? That can inform you that something could be wrong in your production in relation to maze card attacks. Add that into the system where you're communicating with others. In my company, that is Microsoft Teams. So what I did for my company is that I added a specific post function that posts in web Teams when an alert is created. And in this case, I'm showing it at the bottom of the page, and a false positive. You will get that also. That informs me and the developers that we are together in this channel, that something happened on our production. And with that, I think I can say thank you to you all for being here. And if you have any questions, I will be happy to answer.